Grade 10 Math Multiplying and Factoring Polynomials Part 4. Welcome back to Djji Tutorials. Today we are covering factoring the difference of two squares and solving quadratic equations by factoring. So let's dive in. Factoring the difference of squares is a method used to break down expressions of the form a squared minus b squared. This type of expression is called a difference of squares because it represents one square number being subtracted from another. The key identity to remember is a squared minus b squared equals a minus b times a plus b. Example, factor x squared minus 9. First, recognize that x squared is a square which is x times x, and 9 is a square which is 3 times 3. Next, apply the identity x squared minus 9 equals x minus 3 times x plus 3. Why it works. Multiplying the factors back, we get a minus b times a plus b equals a squared plus ab minus b squared, which simplifies to a squared minus b squared. The middle terms cancel out, leaving just the difference of the squares. Alright, let's start with basic variables. For example, let's factor x squared minus 16. First, recognize that x squared is a square and 16 is 4 squared. Now we apply the formula x squared minus 4 squared equals the product of x minus 4 and x plus 4. Moving on to coefficients with variables. For instance, if we need to factor 4x squared minus 25. Notice that 4x squared is the same as 2x squared, and 25 is 5 squared. So, this becomes the product of 2x minus 5 and 2x plus 5. Finally, let's tackle multiple variables. For example, if we need to factor x squared minus y squared, this is already a perfect setup. X squared minus y squared equals the product of x minus y and x plus y. Alright, let's dive into an example involving higher powers. Let's factor the expression 16x to the fourth minus 81y squared. First, we recognize that 16x to the fourth can be written as 4x squared all squared. Similarly, 81y squared can be written as 9y all squared. So the expression becomes the difference of squares, 4x squared minus 9y times 4x squared plus 9y. Now, let's talk about hidden squares and how rewriting the expression first can help us factor it. Take the example of 49x squared minus 1. Notice that 49x squared can be rewritten as 7x all squared, and 1 can be rewritten as 1 squared. So the expression factors into 7x minus 1 times 7x plus 1. To solve quadratic equations by factoring, you'll need to follow a few steps. First, write the equation in standard form. This means making sure the quadratic is written as x squared plus bx plus c equals 0. For instance, if you have the equation x squared plus 5x plus 6 equals 0, you're already set up in standard form. Step 2. Factor the quadratic expression. Find two numbers that multiply to a times c and add to b. In the example x squared plus 5x plus 6, we want two numbers that multiply to 6, like 1 and 6 or 2 and 3, and add to 5. The numbers are 2 and 3, so it factors as open parenthesis x plus 2 close parenthesis open parenthesis x plus 3 close parenthesis equals 0. Step 3. Set each factor equal to 0. Use the zero product property. If a times b equals 0, then a equals 0 or b equals 0. So, x plus 2 equals 0 or x plus 3 equals 0. Step 4. Solve each equation. X plus 2 equals 0, which means x equals negative 2, and x plus 3 equals 0, which means x equals negative 3. Final answer, x equals negative 2 or x equals negative 3. Let's solve a quadratic with a leading coefficient. Example, 2x squared plus 7x plus 3 equals 0. Step 1. Multiply a times c. Here a equals 2, b equals 7, and c equals 3. Multiply a times c, which is 2 times 3, and that equals 6. Now, find two numbers that multiply to 6 and add to 7, 1, and 6. Alright, let's move to step 2. We need to rewrite the middle term, so we'll split 7x using 1x and 6x. Our equation now looks like this: 2x squared plus 1x plus 6x plus 3 equals 0. Now step 3 is to factor by grouping. We start by grouping the terms like this: open parenthesis, 2x squared plus 1x, close parenthesis, plus open parenthesis, 6x plus 3, close parenthesis. Next we factor each group. So we get x times open parenthesis, 2x plus 1, close parenthesis, plus 3 times open parenthesis, 2x plus 1, close parenthesis. Finally we factor out the common binomial, which gives us open parenthesis x plus 3, close parenthesis, times open parenthesis, 2x plus 1, close parenthesis, equals 0. Moving on to step 4, we need to solve each factor. Set each factor to 0, like this: x plus 3 equals 0, which means x equals negative 3, and 2x plus 1 equals 0, which simplifies to x equals negative 1/2. And there you have it. The final answer is x equals negative 3 or x equals negative 1/2. If you find this video useful, please share it with your friends and classmates. See you next time.